Both of you are there, so we should start,
I
madam.
am here and I would like to start. It is quite
Yeah,
late.
yeah, yeah,
Gayatri
yeah, yeah.
madam, are you here? Gayatri madam, are you here? Okay. Anyways, a very warm
You,
welcome to all our participants here, our esteemed resource persons, our colleagues, and officials of SDG Foundation. I'm very happy to say that today we are not just starting a workshop. This is a 2.5 months workshop, but we are also unlocking a portal for you. And Google Earth Engine is that portal through which in this coming 2.5 months, we will be able to see the various facets of Earth and environmental science, and that from our laptops. And I assure you participants that together we will learn to develop a toolkit for the future. And how will this toolkit help you? It will help us in identifying how to process the various satellite images uh, and also to develop live dashboards and Google Earth Engine supported apps. Incidentally, I would like to inform you all that this workshop was planned only for 2 months, but now we have increased this to 2.5 months with various added course contents over here. I would also like to mention that for this workshop, for this 2.5 months workshop, we have got so much participants. So like this represents around 15 subjects and around over 19 institutions have joined us. And here we have a very excellent team of resource persons whom I would like to introduce you to. We have Dr. Jayanto Das over here, and Dr. Das is an assistant professor of the Department of Geography at Rampurhat College, West Bengal. He holds a PhD from the University of North Bengal and specializes in climate change, geomorphology, hazard management, GIS remote sensing, and sustainable agriculture. He is an accomplished editor, author with Springer and leading journals. He has led various international collaborations, organized major conferences, and has received multiple awards for his contributions to geographical research and education. We welcome you, sir. Next, we have Lieutenant Manoj Chandrakar. Lieutenant Manoj Chandrakar is a lecturer in the Department of Computer Science and Engineering at UPU Government Polytechnic, Durg, Chhattisgarh. He holds an MTech in Data Science and Engineering from BITS Pilani and BE from CSVTU Bhilai, specializing in GIS, remote sensing, and Android application development. With over 9 years of experience in technical education, he also serves as an associate NCC officer and has led numerous institutional digital initiatives, including the development of attendance systems and geospatial web portals. We also welcome you, sir. Next, we have Mr. Ayan Ghosh. He's an IT personnel GIS engineer with Special Investigation Division, CAD GIS Center, Government of West Bengal. Mr. Ghosh is a well-known name in the field of GIS training and applied geospatial science with over 17 years of professional experience. He has trained a number of students, researchers, and working professionals across India. He has delivered specialized training and workshops for several prestigious institutions, including IIT Indore, Techno India, Jharkhand Mining and Exploration, etc. He has been associated with various international seminars and national seminars and has successfully conducted multiple GIS internship programs. I also welcome you, sir. Participants, the goal of this workshop from your perspective should not be just certificate collection. It should be acquiring new skills towards solving real world problems. I wish you all an enlightening learning journey. Thank you. If Mrs. Gayatri is available from SDG Foundation, you can please tell us about SDG Foundation. If Mrs. Gayatri is not available, then I would request Dr. Das to start the session.
Thank you, madam. Due to technical glitch, Gayatri madam cannot join. So let me share my screen. So this is our official website of HDC Foundation. I'd like to thank you all the participants join here and resource person join here. And this is our official website of HDC Foundation. It's a very new NGO enrolled in May 2025. We are trying to build the training program. We are trying to build a training program related to the geospatial science. We organize various webinar. But we are now looking for the training program, long-term training program like geospatial, like Google Earth Engine, one of the important tools right now instead of traditional GIS tool. So we are now focusing the tool which will change the environment monitoring, which can monitor the environment, like climate change, like flood monitoring, like actually, we are trying to do the real case studies, right? So our team is a short team, but we are very soon we will announce about our free memberships. Our short teams, you can find our website. I'll share the link, this website here. You can see here about us. We are proud that we have President Professor Bhatoti Vishwas, Vice President Dr. Kuldeep Goswami, and myself, Secretary General, Financial Secretary Piyush Saha, and Dr. Mohammed Shuail Mir, Program Secretary, Ms. Rati Maoi, Organizing Secretary, and Mr. Shyamlochan Bora, Public Secretary of this NGO. So this is actually Section 8 non-profit dedicating NGO to serve as to achieve the sustainable development goal and also in the pathway of Viksit Bharat 2047. So I hope in the future we'll work together with our participants also. Thank you, madam. Bhatoti madam, Gayatri madam cannot join due to some issues. So I request madam to carry out this program. And Manoj Chandrakar already joined. So our first speaker is Manoj Chandrakar. Over to you, madam.
Yes, thank you, sir. And Dr. Manoj, if you are ready with your first session, so you can start the first session.
Yes, ma'am.
We will be having those who are still messaging that you are not able to hear. I think there is some problem with your setup because we are loud and clear. So you can please check your setup, and we also request you that you please set your this thing instead of repeating the same chat thing that you are not able to hear. We are loud and clear. And Dr. Manoj, you can please start the session. Participants, today we will be having three sessions, and the three sessions will be taken by Dr. Manoj, Dr. Ayan Ghosh, and Dr. Das.
Thank you so much, ma'am. Is it my voice is clear to you?
Yes, yes,
Yeah,
it
it
is
is
very
clear.
much loud and clear, sir. Thank you.
Okay. Let me share my screen first. Presentation is visible to everyone.
Yes, it is visible.
Okay. Uh, this is Manoj. I'm very grateful to organizing committee and the coordinator for giving me this opportunity to interact with all of you. A warm welcome to all the participants. I hope you are safe, healthy, and excited to explore something powerful in the field of geospatial technology. In next 30 minutes, my goal is not to make you an expert in the Google Earth engine, but to give you a clear understandings of what it is, why it is important, and how you can start using it confidently. Today, we live in an era where the satellite data is freely available, but handling the large volume of data on the local computer is still a big challenge. This is exactly where the Google Earth engine comes in. Google Earth Engine is not just a software, it is a cloud-based platform that allows you to analyze massive geospatial data sets without downloading them by using a web browser and some simple code. What you see on the screen is an overview of Google Earth Engine. It is also referred as GEE. On the left side of the slide, you can see the key components such as cloud computing, big data, and satellite imagery. This represents how Google Earth Engine removes the need for downloading large data sets or using high-end computers. Everything runs on the cloud. At the center, we see the Earth connected with the major satellite missions like Landsat, Sentinel, and MODIS. The Google Earth Engine hosts petabytes of global satellite data covering several decades and all of which are ready to use for analyze. On the right hand side, highlights the climate layers and the vegetation indices like NDVI. These allows users to study temperatural trends, vegetational health, forest cover change, climate changes at local, regional, and global scale. The chart shows this represent how quickly how quickly the Earth engine can turn raw satellite data into the meaningful insights using fast parallel cloud computing. In the simple term, Google Earth engine help us to move from data collection to the decision making very efficiently, making large scale environmental and geospatial analysis scalable to the student, researcher, and the professionals. In the next slides, you can see the Google Earth Engine GUI. Here, it shows the four different window, or you can say panel of the Google Earth Engine editor. On the left side, we have what we call manager panel. This includes the scripts where we can save and organize our JavaScript programs. The second tab is Docs. Docs tabs provides the complete API documentation for the Google Earth Engine function, which is extremely useful for the coding. And third tab is Assets. Assets section is our personal cloud storage where we can upload or manage shapefile, raster data, and other resources. In the center, we have the editor panel. This is where we write the Java code to process satellite and the environmental data. The editor supports highlighting and provides run and resets button, allowing us to execute the script in script instantly on Google Cloud infrastructure. On the right corner, we have console or inspector panel. The inspectors allow us to click anywhere on the map, which is here, and retrieve the pixel information, which is very useful for the validation and analysis. The console displays the output from our code, such as text message, numerical result, or charts. Finally, in the bottom, we have the map panel. This is visualization area where all the results are rendered geographically. It supports both map and satellite view, allow us to interact, explore spatial pattern and analyzing results. Let's begin some live demo of the Google Earth engine. For this, what you need only the Gmail accounts. You simply type here Google and type disconnected. Google. Is it visible?
Yeah, it is.
Okay. You have to type now connected Google Earth engine. 190. Sorry. What you need only the Gmail accounts, and here in the Google search panel, you simply type Google Earth engine. Once you click this, you will go inside this website. There is in a right corner, I hope it is visible. In the right corner, there is an option of get started. Once you click it, it asks you to log in through your Gmail accounts. It's a simple step. You just click your Gmail account and you will able to access the Google Earth Engine code editor. For you, I have already logged in my Gmail accounts. So let me open here. Simply you have to type here in a URL, you have to type code.googleearthengine.com. Once you type this, you press enter and the whole window will appear for you. The all four panels and windows. Let's start some basics here. This is your map panel, and here your scripts, the saved one. This is inspector, console, and suppose I want to search the latitude and longitude of a particular area like Iran. So I just want to know what is its latitude and longitude. I simply click here the inspector panel and click on map. Look here in the right side, you are able to see the exact latitude and longitude of this particular points where I have clicked. Suppose I click again here. Look, it's minute changes because I am in current country. And here is one important point is also there that is called zoom level. If I zoom it more and then click, you will able to see the when we zoom in, its zoom level will increase automatically. Okay, so this is just a way to find the exact location in the form of points. If you want in future to just trace a particular area, here in a map, there is a one icon. It looks like a hand icon. If you click it, then you will able to move your map in any direction. Okay. So if I want to click Dubai, suppose a particular area like Delhi, Delhi of India, it is Delhi. I just want a point for Delhi. I just click it. Now you can see in a map there is one layer is added called geometry, and it has one point. The value is stored in the variable called geometry in the form of point. In a just I clicking in this hands and move the map somewhere else. Now I want to search that map, that point, particular point again in this map. How we can do it? For this, Google Earth Engine has a very good function called set. So it's called center object, and you have to pass that variable which it is created geometry and your zoom level. So I just use it knife. To execute this command, you simply have to click this run button. Once you click it, your map, you can easily see that particular geometry is pointed on the map. At any scale, at anywhere, if you are in the world, once you run this, that map is a, you can say it's a library class. It has one function called center object. And which object you want to center? That geometry object. That is, if you want to change that geometry object to Delhi, you can change it and it automatically change in your code. It's a point for the Delhi. It's a, you can say variable which holds the value. Or you can say cap, whatever name you give that particular point, it automatically reflects in all over the codes. And simply click the run button. It's point. This is the point geometry. If you want to trace some particular area, suppose your study area is some kind of lake or river, and now you want to trace that particular changes in over the decades, how this water body is changed. So you need to trace particular area. There is a one shape. You simply click it, draw shape, and you have to trace the particular area. Suppose I want to trace it in, if you zoom it properly, you can easily trace it like this. What I'm doing, I'm simply clicking whenever I got some turns. I'm not going to click all this area. I simply, okay. So this becomes a polygon. If you want to see this polygon, first check what its value is. It's already stored in the same variable. So whenever you want to run it, it's centered in the same location. There is one another shape called rectangle. You can also use this. Suppose I want to use it for that particular regions of Rajkot and Jamnagar. You can simply drag and drop it. You have to hold the mouse from the start and the end. It will draw a rectangle for you. This rectangle has some background color. You can easily change it by the using of this setting button and icon. Here is different colors available. Whatever color you want. If you want some transparent kind of color, you can choose the lighter one. Here, that particular area is marked. And you can easily see one another variable is created called geometry. Again, it's a default name for the variable is geometry. Now, if you want to center again for this geometry, you have simply has to copy and paste it here. For you, I just move the maps. Now I run it. It will center the particular area, that is the Rajkot Jamnagar area. Zoom level is high, so we should reduce it by 7. Let's run this. Now it's better. This is a way how you can use or this kind of shapes, polygon and points, rectangles. Let's explore what kind of data it is having for you. So Google Earth Engine provides you very large data sets. I simply delete this code, and in this search area, we can search the place also if you want, just like we have searched the Delhi. Even you can also search some kind of catalog data, which Google Earth Engine will provide. Hello, is there any question?
Participants are requested to mute yourself. No, sir, there is no question. You
Okay.
can please proceed.
So now we have to browse some kind of data in Google Earth Engine. There is a option in search area. Simply browse the data catalog. Once you click it, here the some major satellite missions and their names are already in a top called the Landsat, MODIS, Sentinels, and some surface temperature. Others data are also available. I simply show you one or two satellites data, how you can explore it and how you can use it in your study. So firstly, I click that Landsat. Here are the collection of Landsat satellite data. It are the satellites which were launched in different temporal times. For Landsat 1 to 5, the data is available for the year of 1972 to 99. Similarly, the latest Landsat was launched called Landsat 9, and it has data from 2021 to present. So whatever your study area, you can select the satellite based on the time. So first I click this Landsat 9. Here, Landsat 9 will provide you different kinds of data sets. One for surface reflection, one for top of the atmosphere and raw images. For me, I just select the surface reflection. There are two different buttons is available. One is called Tier 1 and Tier 2. It's just an server where you can use the satellite data. For me, I just use the Tier 1. It calls data availability. Here you can see the date from where the data is available. It's a 31st October 2021 and till 8th of Feb 2026. It means 3 days before we have data, and it's interval of 16 days. It means it will revisit the same place after the 16 days. The data set is for Google Earth Engine. And here one important thing is the double E. Double E is an offset of Google Earth Engine, which provides you the all image collections where this data is stored. So it says code SwiftNet is image collection, then satellite name, and some type. What you need, you don't need to type a huge code for just travels this data. You simply click this arrow button. Once you click it, the Google Earth Engine will automatically give you the code snippet for the viewing this particular Landsat data. You can simply change its range. You know that the interval of for Landsat image is 16 days. If you want current data, you can simply change the date from to date. It's 1 month data. Here it search for 1st January 2022 to 1st February 2022 data. The filter is just a method which we can apply on this data set. Okay. Next is scale function. In detail, we will talk in other lectures, but for you, what it is important, we know already how to find the latitude and longitude of particular area. It's default somewhere else. So if I will search in a map, there is an India map. And if I am going to search the latitude and longitude of this particular area, Nagpur, I simply click the inspect and click the Nagpur. Now I know the latitude for Nagpur is this. I have copied and paste in this area. And next is longitude. Once I will run this, it will give me the true color of that particular area. These are the bands for the combination of RGB. We need this band, true color compositions, 432 it's called in technical terms, and the band number we should know. But for you, the Google Earth engine is already gives you the ready-made code so that you can know what is the band we should apply in that satellite image to get the true color composition. So once I run this, it will center the map to the Nagpur and give me the area. Okay, so let's run this. It's centered the Nagpur and it gives me the Landsat live Landsat image, not the live image. Uh, For that particular times image, it gives me the in the scale of 8. If you see the whole world's image of Landsat 9 of particular duration is available, but you want only
Manu sir, you are muted. Unmute yourself. You have to unmute yourself, Manu sir.
Okay, okay.
Yeah. Okay.
Now audible. Okay.
Yes,
Yeah,
sir.
audible, audible.
So we can simply clip this map by particular dragging this area and the geometry which we want to clip. Simply type the geometry 2 and that's it. If we run it again, look at the map. This time we see the Landsat 9 image only for that particular geometry. If we change that geometry color, you will be visual Much better. Okay, now it's visible for all of you. So that is the one easiest way you can use or explore the satellite image of your interested area whenever and what date you want to explore. There are so many other functions also available. We will discuss it again in some other classes or in this whole course area. I also want to show you one of my project. It takes only 2 to 3 minutes where we can use this Google Earth engine to explore such data of Landsat or MODIS. This is only the 5% I am talking to you. The 90% is still remaining. So you have to select this kind of drop down or menu we can easily create with the Google Earth Engine's code editor. You can select any state here, all the state of India is available. Let's select the Mizoram and particular districts. Here is you can easily see that particular districts is selected and its color is changed to dark. Look at the particular district's map and you have to select some date. If I want to see the latest image of Landsat 9, I simply have to give the date range. That website will automatically get the latest satellite. It select the latest satellites. If that time the Landsat line is data is not available, it goes for Landsat 8 or it goes for 7, 6, whatever times you have given. Look how it works. I'm going to change the particular zone and whole four window will changes simultaneously. And you are able to see the particular district's image in four different way. The vegetation map is there, the land and water, the false color combination, and true color is also there. These all are used in different purposes. So this is a one of the way what we can do with the Google Earth engines. That's all from my side for today class. We will learn this in upcoming classes, how we can develop such kind of dashboards or how we can integrate this Google Earth engine in your own website. So it's okay. Thank you so much. Sir, over to
Thank you
you.
so much, sir. Yeah, so thank you so much, sir. And I would like to tell the participants that sir has developed his own website with this GIS special geospatial techniques, which we will be seeing in the coming classes. This was just a glimpse of what you are going to see. And before I call upon our next resource person, I would like to just share with the participants what we are going to learn in this over this period of 2.5 months.
Madam Gayatri madam also joined.
Okay, so Gayatri madam, have you joined?
Yes, ma'am.
Okay, so is my screen visible?
Yes,
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 yes.
ma'am.
Yes, so participants, this is all that you are going to learn over this period of 2.5 months. So I hope you can see what all we are going to teach you. And as told to you before that this our workshop is not aimed just for certificate production. This is also we want you to have your own mini project, and so we at the end of the 2.5 months, you should be able to have your own projects. So we will be starting with the basics, and then we will be going to more advanced level in part 2, and then further more advanced in part 3. So thank you, and over to Gayatri madam.
Am I audible, ma'am?
Yes, you are audible.
So, good evening, everyone present here. I would like to take a moment to briefly introduce Srushti Drushti Geospatial Foundation to you all. True to its name, which translates to creation vision, the foundation is dedicated to creating a sustainable future through the power of geospatial vision. It strives to democratize geospatial knowledge and empower individuals and communities with mapping tools and spatial analysis skills. At SDG Foundation, our aim is to strengthen geospatial awareness, promote specific learning, and build platforms where students, researchers, and practitioners can exchange knowledge. Events like this webinar and workshops helps us to go close to that vision. SDG Foundation is flourishing under the guidance of Secretary General Dr. Jayanto Das, Assistant Professor at Rampurhat College. Our team also has distinguished experts from geospatial technology, including Dr. Kuldeep Goswami, Vice President of SDG Foundation from Dibrugarh University, Ms. Piyu Saha from North Bengal University, Dr. Mohammad Suhail Mir, Program Secretary, SDG Foundation from Chennai, Mr. Shyam Lochan Bora, Publicity Secretary of SDG Foundation from Dibrugarh, Assam, and myself, Gayatri Maure, Organizing Secretary at SDG Foundation from AISSMS IOIT Pune. If your aspirations resonate with our vision, I would be happy to welcome you all to Team SDG Foundation as a member. Few of the membership perks include free access to resources, like our team has huge database of publications, internship community, then community support, free access to webinars, and special discounts to the paid workshops. These membership forms are about to release, and the membership will be absolutely free. For more details and being connected with us, you can join our WhatsApp group. Link of this WhatsApp group I will share in a while on chat box. For more details further, you can visit to our website sdgfoundation.org.in. The foundation is committed to fostering a vibrant community of geo enthusiasts and professionals. And events like today's webinar are core part of our mission. So with this, I thank you once again to everyone who have joined us today here. We look forward to a rich, engaging discussion. So, ma'am, can we invite our second
Thank you,
speaker
madam.
now?
Yeah, thank you, madam. I now invite our second resource person, Dr. Jayanto Das, to have his session.
Thank you, madam. I hope my screen is visible. So, madam already shared.
Yes.
Yeah, madam already shared the syllabus of all workshop, 2.5 man workshops. So basically, we have divided this content into 3 parts. Part 1. So Manu sir already talked about our first topic, introduction of GE environment. What is GE, advantage about the traditional GIS, interface, walkthrough, Earth Engine code editor, how it's work briefly, because today we have very limited time. And definitely we'll go through from, this is a basic to advanced course. So definitely we'll go through from GEE, JavaScript basics, working with raster data, vector data, understanding image collection. So you can understand the basic things. If you can understand, then definitely in the era of generative AI, you can definitely use GE platform to prepare your papers to for your research work, for your PhD work, uh, very easily. And in our second part, if you see, second part talk about today, we'll talk about talk by our another resource person by Oyan Ghosh. So here basically we'll show how we can use the various indices, spectral indices, how we can prepare the changing pattern of these indices with the time, and how we can prepare the supervised classification. So, and the last part, this is our project-based part. So here we'll use some models, like we'll prepare soil erosion mapping or flood mapping or landslide mapping based on the requirement of our participant. Because we got participant from various diverse field. Definitely we talk with every participant and we'll decide which models will align with their goal. So we'll check it. And another important part, this is the crop classification and species classification. This is the second or third level LULC classification. And in GE platform, we have various types of machine learning or algorithm, and we'll use it for preparing this. And if you see in over the internet, and uh, just go to Google Scholar, then if you search the crop classifications in GE, then you can find many papers which are published in a very good journal. See one journal, Remote Sensing, in 2020, and also 2025. See crop classification use in Google Earth Engine, leveraging Sentinel 1 and Sentinel 2. Okay, and it's published in Geospatial Information Science, very good journal from Taylor and Francis, published in 2025. Also in 2026, also definitely you could find these types of publications. Crop type classification using Sentinel-2 images and AI-enabled method for precision agriculture, right? So see, it is published in Elsevier journal, crop classification mapping in multi-cloud region. So how we can integrate? So my today's lecture, basically I will focus on case study, how we can uh, prepare one paper based on this course, crop classification and species classification. This is second level classification, LLC classification, or we can say it is third level classification. We can also estimate the yield of any crops, right? So here, first of all, I would like to thank you, Department of Geography and Resource Management, Mizoram University, and Srishti District Geospatial Foundation for giving me this opportunity to talk about this platform, because GE now free. Of course, anybody can use it. This Manoj has already told about their large data set. No need to download any data set. This Google Earth Engine basically use the cloud platform. So from the cloud, we can prepare our maps. Basically, if you want to work in a large study area, you cannot use the traditional desktop GIS. That's the problem. Definitely, we need to use the desktop GIS in many purposes, but for modeling, we cannot use. If you select a study area like one state, you cannot perform these types of analysis in desktop GIS. That's why Google Earth Engine is required. Obviously, uh, you can use here not only the JavaScript, Google Earth Engine based on the JavaScript, but we can use also Python code in Google Earth Engine. And from here, we can integrate it with the Google Column. From here, we can integrate it with the Python. Then we can prepare a very good paper. We can publish it. I hope you all can publish after completing this workshops, right? So focusing on today's case study, that is crop classification. My objective is clear: to assess the crop classification uh, and integrate and fuse these two data sets. We have Central one SAR data and Central two optical data set in Google Earth Engine platform. So here I have used this SAR and Central two data set, and here I have chosen two classifier. One is random forest machine learning classifier and gradient boosting tree. Both two are ensemble machine learning method. And also I have fused with the various dates. I'll talk about it why I fuse various date and what I got the result. I'll show you. So first of all, this is my study area, Udham Singh Nagar district. So any geospatial analysis cannot do without the ground truthing data. So we need ground truthing data. We have collected. This is a collaborative work. So we have collected 1,141 data set from the ground using the GPS survey. This is Udham Singh Nagar districts of Uttarakhand here. This is one of fertile soil is there. This district actually uh, uh, actually huge agricultural potential area. That's why I have chosen these districts for this demonstration, and I have used some crops like wheat, mustard, sugarcane. These three are major crop here, okay, dominant crop here. That's why I have chosen this main crops here: the wheat, mustards, and sugarcane, and all crops are different types of phenology. So you cannot compare the wheat crops with the mustard crops phenology, also sugar phenology, but we can successfully classify using this two machine learning technique, random forest and gradient boosting tool for classify these using Google Earth Engine. So Manoj sir already showed the interface of Google Earth Engine. This is the interface of Google Earth Engine, and this is the code I have used here. So I'll explain how we can prepare your data set. So all data set are available. No need to do, just you have to collect the ground data. You should go the ground. Don't collect from Google Earth Pro. My advice is go to field, collect your data set, then use Google Earth Engine or any platform like where you don't no need to download these huge types of data set, right? To classify your MS. I will explain why one by one. Manoj already told many things about the basic part. So I'll basically focus what will be the output after complete this workshop. So definitely, if you want to publish one paper, you need to prepare, you need to describe your study area. So this is my study area I have prepared. Like you should prepare. I have used here, this is not the Google Earth Engine view. I have used probably ArcGIS. You can use QGIS or any desktop GIS for preparing these types of map. So you can see the training data: urban, forest, water body, wheat, mustard, sugarcane, and river bed. I have collected from field survey and divided this data set into two, 80% for training data and 20% for testing data. Now, important part is how you can classify this data set into 80 and 20%, and why you selected 80 to 80 and 20%. So by literature review, you can find there are many technique to divide this data set training and testing. Some use 70%, 30%, 75%, 25%, 80%, 20%. So because I have selected such kind of crops which are not the similar phenology, that's why I have selected 80% for training data, right? So and then in Google Earth Engine there is one code random. Okay, so I have used here the random classifier to classify this data set 1141 point data. It's not a area data. Don't take the area. We need to take the point data. Okay, so point data. So now you can ask how we can collect this data. It's very difficult to collect the field data. Don't use mobile. Use the GPS and go to the enter the field. Okay, and from the middle of this field collect the point data. Don't mess with others data because in GPS there are 3 to 5 meter error. So that's why we have to collect from the middle of the field. GPS point from the middle of the field. right? So after collecting, you have to go in GE part platform. Now I have used here two data set. One is SAR, another is optical. So why? You can use also only the optical. You can also use only the SAR data set. But I have used the both data set to get the more accuracy, to get 100% accuracy. Okay, and my target is how we can um, we can predict in early stage, not the middle stage, because it is the issue of our issue of our food security, issue of our market management. If we can predict in early stage, then we can manage the market. Okay, if it is shorted, then we have to import from outside. Uh, if a crop is more than sufficient, then we can export also, right? Now, yes, Central 1 and Central 2 data set. For Central 1, I have used two types of band. One is BB band. BB matlab, BB mean vertical transmit and vertical receive. And VA is vertical transmit and horizontal receive. So I mosaic these two bands, vertical, and vertical horizontal. And I have considered this in informative wide swath. Okay, informative wide swath, that is called IW, mode. And in case of Sentinel-1 dataset, there are, because the SAR dataset is a descending pass and ascending pass. So I have considered the ascending pass. You can consider also descending pass. No issues there, but I have considered the descending pass, right? Now for the optical data set, see here, I have considered data huge number of data set from band 2 to band 12. Manoj told about the surface references data set. So I have considered here the surface references data set. If you use the surface reference data set, then you have to use the scaling. So that's why I have multiplied by this value for scaling purpose. Okay, Manoj show you. And for the time frame, okay, I have considered here three time frame. First time frame, date 1, 10 to 15 November. Manoj told about the time interval of Lancet, right? So for Sentinel, special temporal resolution is 5 days. So we will get the image every 5 days. In case of Lancet, it's 16 days, but in case of Sentinel, it is a 5 days. That's why I have selected the 5 days window, 10 to 15 November, 15 to 30 November, and 15 to 20 December. So how you can decide who is typing you should select? It's based on the phenology of crop. Okay, so it will not work for your area probably. So you need to prepare the crop calendar. Based on your crop calendar, you have to select this one, November. This is the early stage crop. This is the middle stage crop. This way you have to select, right? Then ground truthing data, I have already told you, I have collected. Okay, then you have to mosaic these data set, Central 1 and Central 2, for preparing your model, final model, right? If you see, this is a methodological framework. I have no need to download the data sets by God, because I have used a huge data set here, Central 1. For Central 1, it is important, if you use the SAR data set, you need to use some filtering. Okay, so I have used here the speckle filtering, Lee filtering. Okay, in Google Earth Engine, Lee filtering are available. In other software also, Lee filtering also available. So we need to use the Lee filtering. Okay, for VB and VAs, I have used the Lee filtering. Then I have considered here that there are various types of Lee filtering. I have used the enhanced Lee. Okay, and for Sentinel 2, this is the important thing. We need to use the quality control. There is a band, the quality control band. Okay, QA60. This is a quality control band available in Sentinel 1, Sentinel 2. So I have used here the QA60 quality control band for masking the cloud. So before using, this is the pre-processing test, before using B2 to B12, when it is a resolution of 10 to 20 meter. Some bands are 10 meters, some bands are 20 meter, but the SAR data set is at 10-meter resolution. So before using this, we need to use this QA60. It is available. It is available in Google Earth Engine. So after doing this, we have to merge it. Okay. Now that's when you are fused two data set. One data set is Sentinel-1 data set, there is SAR data, and another Sentinel-2, that's optical data. So you can fuse these two data sets, SAR data and optical data, for preparing your final map. You can see here. So if you see my console here, see. So I have collected it data set. So how you have to prepare? Just you have to prepare this way. Monu sir told you how you can prepare this E. This is a code. If you add the point data, then this is geometry data. So I have added features as geometry. That's why E features as geometry. E is geometry dot point because it's a point data. Now this is my point value. I got this by field survey, by GPS survey. Okay. Now I use at the zero. I use at the zero. Actually, zero mean here the urban land. Okay, you can use also one. Okay, zero class zero mean urban land, and for here up to 100 data set I have. Okay, 100 data set I have, right? Then you have to prepare other class like class one, class two, class three. I have classified into 7 groups. See, this is the class. This is the color code, standard color code here. Okay, this is the class one. Okay, then class 2, class 3, class 4, and you have to upload these data set. You have to import these data set in your Google Earth Engine here. Okay, in class I will show you how you can import it. Then you study area. You can say region of interest ROI or area of interest AOI. Anything you can say it, right? So my region of interest is district. So if you use district, then if you don't have any district map, then still you can use it here because POW dataset are available. See, this is the POW dataset in Google Earth Engine platform. These dataset are available, district level dataset. Just you have to select the name of this district, nothing else. Okay, then it will reflect in your study area. Now, first thing, two types of data sets I told you I have used. So I mosaic the all data sets. I told you we need to mosaic. Okay. So how I mosaic it? Because we have three types of data set here. Baby BAs. See, I have selected BB and BAs. Spatial resolution here 10 meter, and I have considered here the I IW instrument mode is IW. Okay, I'll share the code. Don't worry about it. You can directly use it. So one is BB, one is BAs. Then you have to mosaic it. Okay, function of mosaic is here. Gets one mosaic, start and end. Okay, then it will label as this S1. It is short by this. Okay, mosaic and clip as per our study area. We have selected our study area ROI here Udham Singh Nagar. So this is ROI. Now Sentinel-2 dataset we have considered B2 B12 dataset. Now I have considered here clouds. In case of optical data, definitely there may be some cloud. So we have to consider the cloud. So here I have considered 10% cloud. I have allowed 10% cloud. Now we need scaling. So here I multiplied by 0.0001 for scaling it. Okay, then again mosaic it. Now see the various date I have. I have selected 3 dates. So this is the first date, then second date. This is the first date for Sentinel-1, first date for Sentinel-2, then for second date for Sentinel-1, second date for Sentinel-2. I have selected and mosaic. Okay. So now I combine all these data set. I composite all these data set into a single frame. Okay. Into a single frame. And in case of null value, I have used a minus triple line. This is the function. Now main part, this is the classification. So there are four types of classifier are available in Google Earth Engine. Machine learning classifier are directly available in Google Earth Engine. No need to use the external software or external thing. So here, uh, random forest one classifier I have used, and another classifier I use the GPT. Okay, so after composite all these data set into a single frame, I have used RF and GPT. So I is a random forest simplified, okay, and this is GBT. Okay, both are ensemble machine learning algorithm. But in case of RF, random forest algorithm, it's this algorithm build a multiple decision tree. See, it's create multiple decision tree, T1, T2, T3, okay, and this combine their output to improve the classifier accuracy. And final class from here, okay, we got the classifier. So main principle this random forest is bagging. Here use the bagging, and in case of gradient boosting is use the boosting. That's the difference. Principal difference is random forest use bagging, and in case of gradient boosting, it is used the boosting method, right? So after preparing this, I have prepared 6 maps. I'll tell you why I have prepared 6 maps. First, I have prepared a classified second tier classification or crop classification by using the RF, using only central data. Then only central 2 data, that's optical data. Then I have used these 2 data sets, central 1 and central 2, and prepared the classification technique. Then GPT, okay. Then I have used the GPT, and I'll show you the GPT method only. So gradient boosting tree for central 1, then individuals using the individual central 2, then combine it, okay. Then if you classify it or if you prepare any model, then definitely you need to validate your model. You need to calculate the accuracy. So I have used here the confusion matrix. I prepared first confusion matrix, and from this confusion matrix I have prepared overall accuracy, then producer accuracy, user accuracy, kappa coefficients, then also features importance. Which features are important? Because in some cases, if you need to process some data, then definitely you will try to use the minimum data set. Okay, if you use the minimum data set, then your cost will be minimum. That's a piece of importance important here. Okay, so I already told I have used 80-20% random sampling, and for classifier this is important. Random for random forest I have used at 100 tree. So why not 150? Why not 250? Definitely, I'll tell in the class section because it is details methodology. We need to know the principles, how it's work. And also for ZBT, I have considered here 150 T's and shrinkage is 0.1. I'll tell you how you can select, right? Now, band combination I told already. So now, first of all, I check the phenology of these three crops, wheat, sugarcane, and mustard. So to learn the phenology, these two curves, I have used the NDVI of temporal profile. This is the NDVI of temporal profile. Okay. If you prepare the NDVI, all available image from starting to end of this crop period, then you can prepare these types of profile. Then you can understand which date you should pick. Okay. So this is the classified. See, this is GBT 1, S1, S2, S3. Okay. Just see this classification accuracy. Okay, I classified it, then use desktop GIS, and from this desktop GIS I classified, I calculate the area, percentage of the area, and all these here also using the RF model. Okay, and now important part is here the accuracy. In case of Sentinel one, see, just focus on this overall accuracy, or if I see this comparative assessment of producer accuracy. Okay, it's urban. It is very easy. See here, we got 100% accuracy here. Using this three data set, we got 100%. No issues there. If you use Sentinel-1 and Sentinel-2 data set, definitely you can accurately classify the urban area. You can accurately classify the forest area and water body area. No issues there. See, accuracy 100%, user accuracy 100%, and F1 score also 100%. Producer accuracy, all cases producer accuracy 100%. Okay, so no issues in classify the first level classification, that is urban, forest, and water bodies. Now problem in when you classify the crops. See, in case of wheat, we got highest accuracy in case here. Yeah, this one user accuracy 100%. When you combine these three data set, two data sets, Sentinel-1 and Sentinel-2, for three dates, 1, 2, 3 mean here, date 1, date 2, date 3. That's when we have 6 data set. By combining these 6 data set, we got 100% accuracy. And in case of see musters, so here, here this one gradient boosting, this R mean here the random forest. So from gradient boosting tree, we got very good results. See here, we got producer accuracy, we got 100% accuracy in case of sugarcane. In case of musters, here also 100% accuracy. Okay, polar in case of musters, in some extents, musters you cannot successfully classify musters because of the flowering, because of the crop phenology. Now, this my result, and I believe that if I submit in a standard journal, I can publish this paper. I didn't submit it, but I'll try to submit it. And I talk about the feature classification. I don't have so much time. Just feature classification in C. In case of GBT, it's used vertical data is accuracy 16%. So no need to use this data set because of GBT. But in case of random forest, you need the many data sets. That's why GBT is important instead of random forest. Now, how we can use it in Google Earth Engine? That's the question. That's why you are here. So I have classified this data set. Like I have this data set, training data, plus urban land I have. Forest, water body, wheat, mustard, sugarcane, river bed I have. Then I composite this training data here, fuse, SAR, and optical band. Then composite all sample region, training level, and scale. I have selected here the 10-meter resolution because Sentinel-1 and Sentinel-2 basically 10 meter. Okay. Now see this is the random column training data. I have used the random function to classify 80 to 80%, 20%. And as I told, I have used filtering, enhanced leaf filtering here. Okay. And then random 0.8 for training data. And for GBT classifier, I have used the number of trees 150, syncage 0.1, and max node 16. This is not a fixed. You cannot fix it 150, 0.1, a max node. Okay, this is a trial and error process, and there is a methodology how you can select which number is suitable for your classifier. Okay, it's not a fixed. You have to change it accordingly. Then it will classify was told about the color done in Google Earth Engine available. So just I have used it. Okay, and then accuracy also available here. Okay, for kappa coefficient, everything is available here, and variables. Then relative importance. Then finally we need to export our dataset, right? So just we have to run it. Then it will work. Then you have to export this dataset. So we have another speaker today. So I'll know not carry out it. So definitely in the class, I'll explain one by one how you can prepare in your area. Not only the crop classification, you can prepare the soil erosion using any model like existence model like Russell model also available here, USLA model also available here, right? See, it's calculating overall accuracy, producer accuracy. Then we can export. See, it's working. We can export this. Okay, see here. Okay. So, so if you have any question, definitely we can ask. You can ask after completing the answers lectures. Okay, over to madam.
Thank you, sir. Thank you, sir. I now invite Dr. Ayan Ghosh, sir, to share his session, to start his session.
Thank you, madam. This is Anand Ghosh over here. And first of all, I am really honored to be here, and I want to uh, give my thanks to entire organizing team for giving me the opportunity to share my views, share my experience to all of participants. So without delaying, I shall start my sessions. And as today's is a workshop sessions, and it is true that in this stipulated time frame, that means in today's sessions, it is not possible to make you learn entire Google Earth engine. What we are doing, usually we are trying to make you understand that what is the capability of Google Earth engine in the modern geographical research and geospatial science. So what Google Earth engine can do, what advanced geospatial science can do. So there are lot of new technologies, lot of new algorithms, lot of new machine learning methods over there, and we wish to make you learn one step by step from the very beginning to master. So from the very start to once you after completions of the sessions, you may able to execute your project. So it's a what I believe, what I suppose, it's a wonderful initiative for the organizations from the end of organizations team. So without delaying, what I today I will make you learn, what I want to make you understand that what is the capability of this Google Earth engine. So just I want to share my screen. Just wait a bit. Is it visible right now?
Yes, it is
Is
Yes,
it
it
visible.
is.
okay?
Yes, sir.
So let's see. Google Earth engine. It's a totally cloud-based geospatial application platform. In coming days, this technology will lead entire geospatial science. This cloud-based geospatial platform. So what do you mean by cloud-based geospatial platform? So just I want to give some brief about Google Earth Engine platform. So one by one, just go with me. We will learn lot of new things from the very basic of JavaScript. You people might be sick about that, think about that. We don't have any idea about coding, about JavaScript, about Python. So how do we people will able to execute Google Earth Engine? But believe me, don't need to worry. We will start from the very scratch. We will start from the zero. First of all, we will make you learn from the very JavaScript, from the very basic, from the variable, from the listing, from the very basic. We will start JavaScript. After making you learn JavaScript, then we will move on the geospatial platform, how to implement JavaScript in the geospatial platform. So before that, going to learn Google Earth engine. If somebody asks you what is Google Earth engine, so you should have a very basic concept about what we are learning and why we are learning, what is the implement of that particular technology. So basically, just go with me. Google Earth Engine is a cloud-based geospatial analysis platform. This is more important. While we are Google Earth Engine platform, we don't need to store entire data in your computer or in your hard disk. You may use huge numbers of satellite image, huge size of satellite image, but you don't need to store all those images to your particular laptop or computer or your own storage unit. Just like any cloud-based platform, like your Gmail, like your Facebook, like your Instagram, like your LinkedIn profile, they are using cloud-based platform. Let's say what photo you uploaded in the LinkedIn or Instagram or Facebook, that doesn't store your computer, that doesn't store your computer. It's in a cloud platform. So wherever you will open your Facebook or Instagram or LinkedIn, you can able to see the photo. Whoever will open that your account, he or she can able to see your photo. That means that doesn't matter whether your computer still keep your photos or not. If once uploaded on the cloud storage unit, it will stay for a long time. So this is the platform. Just like nowadays we are using Google Map, it's a cloud based platform. We are using Swiggy, Zomato, all are cloud based geospatial platform. It's a the GIS engineer make it in a very lucid way, so that the people who are using Swiggy, Zomato, Google Map, unknowingly they are in the environment of geospatial platform. They don't aware about that they are using a cloud based GIS platform, but that is so much lucid, so much easy, that one layman can use that kind of cloud based platform. So Google Earth Engine is a cloud based geospatial analysis platform that enables user to visualize, analyze satellite images of our planet. So we can visualize, we can analyze, we can do so many geospatial analysis, starting from vector and raster. You don't need to have any conventional GIS software or GIS applications. And and sometime while you just say you are become a working professionals in the GIS platform, so you need to travel a more and more. So all that time, it is not possible to carry entire data with a hard drive or pen drive or your laptop. It is never possible. But why what you will do in that case? If you use that kind of geospatial platform, wherever you go, you don't need to carry your data with separately with hard disks or pen drive. If you work with Google Earth Engine, you just share a link just like a Google Meet, and your partner or your client can easily able to see entire data, starting from code and the to output. It may be raster, it may be data vector. Entire geospatial analysis like NDVI, image classifications, land surface temperature, ocean surface temperature, so lots of things, over huge numbers of data is available over here. You don't have any idea what kind of data you can able to have very easily. And let's say if you want to download one Landsat image on your computer from USGS site, once seen, while it is downloading, it will take a lots of time. But while you will use Google Earth Engine, you can able to download the image, visualize the image of entire world within a few seconds. So there is no confusion that Google Earth Engine is going to lead in coming days in the field of geospatial platform. Not only Google Earth Engine, but also entire a cloud-based geospatial analysis. We will shift from desktop to cloud-based geospatial analysis. So Google Earth Engine is that kind of thing. So Google Earth Engine is a cloud-based geospatial analysis platform that enables user to visualize, analyze satellite image of our planet, and scientific and non-profit uses of Earth Engine. That means you don't need to pay anything for using the Google Earth Engine. It's absolutely free for everyone. If you want to use for your research purpose or your or for your professional work purpose. So lots of use over there in the geospatial platform. So I always insist you and encourage you, just go with that advanced GIS remote sensing platform. So now next we will move to our next slide. So what is the advantages of Google Earth Engine? So why we will use Google Earth Engine? What is the advantage? So it has various number of geospatial data sets, includes Landsat, Sentinel, Modis, numbers of geospatial data set, and there is some process data also, climate and weather data, land use, land cover change, terrain, and croplands. What sir was saying. So lots of data are all few data are already available over there. So you need to use according to your requirement. But before that, you need to have a clear concept of JavaScript on JavaScript or Python. That means you need to have a clear concept of coding. So if you have the clear concept of coding, you can able to juggle with the code, and you will have the wonderful and outstanding and mesmerized result while using your Google Earth Engine. And once you are engaged with that kind of platform, you will not able to sleep until completions of your code. It's very interesting. Believe me, it's outstanding. Anyway, so there are so many steps, so many progressive steps over there. So just I want to share all those things, a very stipulated with a very stipulated time frame. So first of all, one is data. Data is very important in the case of Google Earth Engine or any geospatial platform like multispectral, radar, aerial, climate, land use, land cover. Lots of data are available. Few are raw data and few may process data. You need to use according to your requirement. You may use some choropleth map, you may use thematic map over there, just with the use of code. You don't need to, and if you don't need to carry your laptop also, you just need to carry your tab and reach some different locations if it's required, and open your once again open. You should have just one browser having a fast internet, and then you can able to solve your all problem regarding geospatial science. And next, API means applications programming interface. So there are lots of API over there. JavaScript, Python you can use for implementing all those things. So in our case we will focus on JavaScript, but Python is also another options over there, still options over there. And now computations and browse based IDLE. So with the help of those algorithm, those methodology, we can easily able to solve our problem regarding GIS and remote sensing. Now next, so somebody may get a little bit of confused regarding Google Earth and Google Earth Engine. What our observations during various numbers of interview sessions when I went for interview to participate to the participants. So do you have any idea about Google Earth Engine, and what answer they came from their end? We can understand he or she was asking for Google Earth Pro. So Google Earth Pro and Google Earth Engine, it's not same. There is a huge difference between Google Earth Pro and Google Earth Engine. Google Earth Pro is a just used for visualize your earth surface. It is not full-fledged AGIS software. It is just for use for visualizations of your earth surface. May some vector tool, few vector tool over there, but once again it is very useful and it's very efficient. No questions about that. But still, it is not a full-fledged GIS software, and it is not as Google Earth Engine. So GEE, Google Earth Engine and Google Earth Pro is absolutely different. Don't be confused. When somebody asks you, do you have any idea regarding Google Earth Engine? Then you should have a clear concept that Google Earth Engine and Google Earth Pro is totally different. So first, you should have a clear idea regarding this. So already Mono sir shows you all those things regarding user interface. So now I just give you a very bit little bit a concept about JavaScript. So in JavaScript or any programming language, not only JavaScript but also Python, C, C++, Java, .NET. There are in all coding or scripting platform. There is some terms over there. Number one, variable. Number two, constant. Number three, operator. Number four, functions. So one by one, we will make you learn all those things. Don't need to worry about all those things. You will enjoy your coding sessions. And what I saw in maximum cases, maximum now of few, when the numbers of students came from humanities background, they are afraid about coding. How we will deal with this type of coding? It may be very hard to digest, but believe me, it is not at all hard to digest. It is very clear, as clear as water. So just go with us and you will have a wonderful interest for writing script and code. So a lot of things over there: variable, constant, operator, functions, etc. Lot of concept over there, list, dictionary. So we will make you learn all those things one by one. Once you able to learn all those things, then you can juggle with your existing algorithm, whatever the algorithm already exists in geospatial platform. If you have the clear concept of this particular algorithm or geographical applications, just convert this algorithm with the help of code and make your computer understand that we are going to execute that particular things. So scripting or coding is a intermediate language. That language is understandable by computer and you. If you able to learn this language, so what is script? Script means a particular sign of language. Say you may heard about script in cave, just like that. So computer kind of computer is enabled with that kind of language scripting. And if you able to learn this scripting in proper way, then you can interact with your computer what you want to do, what output actually you wish from your computer. If you interact with the computer with the media, this is the media. This scripting language is the media. With this scripting language you can interact with your geospatial platform, that I want that kind of output, and that for that reason we have that kind of data. Then you can interact, computer and you can able to interact, and then you will have a wow, outstanding output over there. And definitely when you are enjoying the coding, it's a wonderful journey for all of you, which I strongly believe. So there are so many concepts over there. We will make you learn all those things. Don't need to worry. We will start from very scratch, and step by step we will provide you the lessons, we will provide you the assignment, we'll also provide you the code according to that assignment. You need to follow and submit on time. And after following this process, it's a continuous process. Once again, it's not a magic that I just you sit one day and you will able to learn everything. It's a continuous process, and it's a logical operations. While practicing, your logical mind will be sharper, and then day by day your logical operations will get much more sharper. Once it get much more sharper, you will able to write much more better code, much more shorter code. So it's just like a mathematics. It's just like a practice. It's just like a one more beautiful example, just like a knife. How much you will use, it will get much more sharper. If you don't use, it will get blunt. So if you use code, you may first time you may get failure, you may get failure second time, you may get failure third time, but fourth time you will definitely get succeed. So don't need to worry about failure. Don't need to bother about failure. Just just go and go, just look forward. One day you will definitely get you will be definitely a technically sound person in the coding. So there are so many concept on variable constant will make you learn all those things. Now I just want to move what applications, just few I want to for getting interest. So first of all you need to get interest. First of all you need to leave all your what while we are getting afraid about all those things, you need to leave all those things. So try to face whatever the problem, just try to face. And if you face the problem, what you can easily able to solve. Just I want to show you what is the power of Google Earth engine and what we can do. This is the one applications of Google Earth engine. That Google Earth engine, so it is a predefined applications. For the time being I am showing because instantly it is very difficult to write entire thing. In this case Google Earth engine showing that how glacier is melting in the mountain region, and with the it is called time lapse. This lots of image, we collect lots of images over there. Having collecting lots of image with the time durations, I just merge all those things and just visualize to you. It's all about code, all about applications, how it will appear. So one by one image is appearing and instantly it is disappearing. So in that way we just show you, I just want to show you the glacier. Initially glacier belongs to stay in that much portions due to repeated due to constant global warming and greenhouse effect, that glacier has been melted out. And this is quite alarming. This is a huge it has a huge environmental effect. Not only environmental but also climatic effect on for the entire world. And this is the alarm, and that alarm is ringed by those applications, those advanced geospatial applications. And that applications pinch on your mind that this is happening with us. This is happening where? This is happening in the mountain region where that average temperature is minus 60 degree centigrade. This is happening in that particular locations. So what is happening with us right now? So that alarm is built by, or that alarm is ringed by that particular geospatial science. You may read about your environmental science book what is greenhouse gases, what is global warming, but you may get a huge number on your numbers on your environmental science paper, but you don't have you don't have the impact on your mind. But this science make you a feel, give you a feel that this is happening with us. Not only that, I just want to show you lot more things. I just want to show you the applications, the power of advanced geospatial science to you. Just I just want to show you what is happening with us. See, so this is the coastal expansions. Coastal expansion means in Arabian country they artificially build some island in the middle of the oceans. And what will be the its impact in coming days? See they are in Arabian country they prepare one island. This in 1980 there was nothing, but in coming days, in recent days, they prepared that kind of artificial island over there. And see what humans are doing. These see this island, those islands are just shaped like a earth, just shaped like a world map. They are playing with their oceans. So I don't know whether they are doing good or not. So definitely it is not good for our environment. So we are modifying our intentionally we are modifying our mother earth. So those are the applications. So those things, not it is not possible to build all those things in a single day, or in a one day. But in one day you will get, in one day you will able to solve, or you will able to prepare all those things. So those are the applications of the coastal. And the same way, there are so many meandering. This is the applications, the people who are dealing with geomorphology, fluvial geomorphology, river erosions, river depositions, siltations. They can use that kind of, so lot of applications. I just want to show you what are the applications area of the Google Earth Engine. So so that you people can understand and you people can get it. See the how the meander is forming, and how the oxbow lake is forming, how the new area is some area is destroying, and the opposite side of the river new siltations is going on. So in that way you can understand the what is the nature of the river in that particular area, why this is forming, and what precautions should I do, how much people we need to evacuate as early as possible. So everything is related to geography, civil engineering, geology, as well as geospatial science. So these geospatial science has that much of power to contribute each and every subject. This is not the this geospatial science is always try to contribute himself to a different sector, that I have that much of capability. What you need, I can provide you, I can produce you. So that much capacity have the geospatial science. So go with the geospatial science, lot of new things to be learned. And in coming days, geography will not stuck in a classroom, or in a geography never been stuck in a classroom or in a college room. It's your entire world, your entire world is a lab. Your entire world is a lab for not only for geography but also geology, civil engineering. So your entire world is a lab, lot of things to be learned. So this is the way to make to reach your destination. So people who are doing research, this is the way to reduce your legwork, to reduce your continuous effort in the practical field. So it, but definitely you need to visit on the field inspections. I repeatedly visit on the field, for the field in different part of India, for execute our project. Sometimes in Madhya Pradesh, sometimes in Jharkhand, sometimes in northeastern part of India, North Bengal, sometimes in coastal region of the India, sometimes in Sundarbans. So I need to visit again and again for the getting the ground truth verifications. But still, that purpose geospatial technology helps us a huge to reduce our project time frame. So another example I just want to show you, those are the minings. What type of how the minings affect on the urban growth and urban sprawling, or urban or sometimes some area is populated in few days, few years ago, and nowadays there is no populations over there. So there are lot of rigorous things happened over there. So that geospatial science always helps us to monitor all those things, and those are related to your daily life, related to your routine. So this is the example of deforestations, how deforestations affect with us. So those are the example. And I just want to show you, this can be done with the Google Earth Engine platform, and you people will so able to execute all those things after completions of the workshops. So lot of new things to be learned. Just see, in few years ago there are a lot of vegetations over there, but day by day, time due to growth of time, the entire area has, the entire portions of the vegetations has been lost. So this is the use of this geospatial platform. And now I just want to show few more things. I know we have time crunch, but still. So this is just a 4-line code. That 4-line code show you the nighttime light emissions of the entire world. And in coming days, how to write all those code, we will show you. Nighttime light indicates us urban and urban sprawl monitoring or urban growth monitoring, how much area has been electrified, and how our earth is looks like from the space and in night sessions. And you can see the area where the electrifications has been done. It's much more, that has much more brighter appearance. Those are the roads, highways. This is the entire, this is the capital Delhi. And you can able to also able to understand this is entire Himalayan mountain region. And this is our desert, Thor Desert. This is, there is Western Ghat in the this is Central Plateau. In that way, you can able to understand how the entire area has been electrifying, and you can also able to understand this is Nile River, and just beside the Nile River there is civilizations, there is urbanizations. That's why it became brighter, and you can also make it transparent for your better visualization. So lots of applications over there. So we will make you learn all those things, how to execute, how to perform all those things. Those are the simple code that has been written over here, and with the help of those code, we people we will just make you learn how to implement, how to write code, how to execute code. And if you had the domain knowledge, if you had the concept, if you have the formula, then you can convert your formula to code, to via code, to make Google, to Google Earth Engine, to get the wonderful results. So be with us, and I hope, I strongly believe that you will have a wonderful experience throughout the session. Still, I strongly believe. And one more thing, I just want to show you regarding our project, what type of project we are doing. Just go with, there is lot of Google Earth Engine applications over there, but I just show right now, I just show you one very simple applications in Google Earth, just to make you encourage in the geospatial field, and what we are doing, we people are doing, and what changes we can able to do with our mother earth for the betterment. Just go with me. So our, there is a huge project named as blue carbon monitoring, blue carbon credit mapping. So we are engaged in carbon credit mapping, and what we are doing, there is a lot of Google Earth Engine applications over there, but I just show you the ultimate result in ground truth, what is happening over there. Just go with me. It will take a few moment depending on the internet speed. And see, this is the last island in the southeast part of Indian Sundarban. And after that, there is a huge forest over there. And for the carbon creations and monitoring, we make a huge plantations over there to protect our mother earth, for mangrove conservations and climate protections. So nowadays, so just go with me, as the just go with me. This is just a case study. I just want to show you. So see here, those are the plantation area, and that plantation area, you can see those vegetations are stayed in a linear pattern. That linear pattern indicates that those area has been planted. But if you move on, if you move on few years back, just go with me. But still it's see, in 2000, 2013, there is that much of vegetations over there only, that much of vegetations. And now 3 to 1, huge number of vegetation has been increased, and our motto is monitored that vegetations count individual in each and every saplings is countable, each and every saplings is accountable. We need to monitor whether does these saplings are surviving or not. So see, there is that much of plantations in 2010, it is 2010, and nowadays 3 to 1. See, that much of plantation has been increased. In that way we are executing our project, and continuously we are mapping with the help of drone, Google Earth Engine, and we need to do a rigorous field survey throughout the there throughout there. So with the help of that technology, I just want to say you that just go with us, be with us, and I always insist you and encourage. And another thing is, just I want to show you, And this is ocean surface temperature. What is the ocean surface temperature in the 2017 month of April? So if you want to change the result, and if you want to see the result of different year, you don't need to process the entire data. Just change the value. So if you have the clear idea, and then you may do what to change and what to change and how to change. Lots of codes are available, but you should have the clear concept of code. If you have the clear concept of code, then you can able to do that three things. What are the three things? What need to change, and where need to change, and how to change. If you have this concept of clear concept of this parameter, you will get a wonderful result. Let's say I just converted 2017 from 2018 and just click on run, and it will get a absolutely separate result. Okay, so if you change the value, the month also, just convert it in one, let's say result of January month, and see the result. It will be changed. So what time it will take? Within a few seconds you will have the entire data of your world. If you use the conventional USGS, conventional Landsat image for processing all those things, it take a huge, but this platform is ready to serve you. Just go with this and don't be afraid. Google Earth Engine, if you learn proper way, if you love, if you passionate with the with your work, definitely you will get success. And we people are very passionate with our job, with our work, with our executions. Unless until you will never get success if you don't passionate with your job. So just love your subject, love your geography, love your geology, love your civil engineering, love your geospatial science. We all together build a wonderful art for our next generation. So I am from geospatial science. Manoj sir is from computer science. Jayanto sir is from geography. Madam from geography. So lots of people from different academic background, different platform. So we all together, we were working all together to build a new era of geospatial science, or new era of geography, new era of civil engineering, so new era of our so we want to build a wonderful future, not only for us but also for our next generation. So that's from here, that's here from me, because already it's 8:13. And once again I would like to thanks Dr. Jayanto sir, Brototi madam, Gayatri madam, Manoj sir, and entire team of Mizoram University and SGD Foundations. And so thank you so much for be inviting me, for for sharing my views to all of participants. And thanks to you participants, you people are outstanding. You are staying with us since last 2 hour, and you people are very give a wonderful ambience to share our views and experience to all of you. And I hope, I strongly believe, in coming days we will have a much more better experience to save our mother earth, to save our climate, to contribute ourselves for our environment. So thank you very much, madam. Thank you very much, sir. And thanks to all of you participants. Over to you, madam.
Thank you, sir. Thank you so much. I now ask Mrs. Gayatri, Madam, to please take over the next few minutes.
Yeah, thank you, ma'am. So I hope all participants have enjoyed this 2 hours intellectual journey with us, and hopefully this webinar has added value to you, and you have got some insights related to Google Earth Engine. If you want to continue with this learning, you can join us with 2 months, uh, our upcoming 2 months workshop. I'm sharing its details. Ma'am, my screen is visible.
Yes, it is visible.
So we are coming with our 2 months online workshop, which will be really hand-holding from basics of Google Earth Engine, JavaScript, and Python coding, and how to deal with satellite data, DEM, and other required datas, right from basics to how we can develop a project and how you can write about your project. You can publish a paper with it. All this will be covered in upcoming uh, 2 months online workshop. Its fees is 5,200 rupees. But as you have joined us today, so from SDG Foundation, we have offered a special discounted value as 4,800. For registration, you might have got this flyer on different groups. In today's webinar chat also, we have shared registration link. If you further have any query, you can contact us on the mobile numbers given on screen. I will again reshare the registration link here in chat box. By that time, if anyone is having any question, you can type it here. If we can take at least 2-3 questions. Some attendees were asking for a recording of today's session. So yes, its recording will be available on YouTube channel of SDG Foundation. Link of that YouTube channel I have shared on chat box. I will reshare it. Further, someone asked about today's attendance. So you need not to worry. We have gathered your attendance, and those who have attended full session will receive certificate for today's webinar. Okay, so I guess there are no questions, and all the content is.
Madam, participant can
Yes.
unmute themselves, and also they can switch the video also. So you should take some snaps for today's sessions.
Yeah, I appeal everyone to please switch on your camera so that we can take a photograph.
Plus, stop share your screen.
Okay. I again appeal all the participants, resource persons to switch on your camera so that I can click some virtual photographs. Your certificates will be shared on your registered email IDs. Okay, with this, I will take this opportunity to thank Mizoram Central University, organizers of today's webinar, and team members of SDG Foundation for organizing today's webinar. I also want to thank our resource persons, Dr. Jayanto Das, Mr. Ayan Ghosh sir, and Mr. Manoj Chandrakar sir, for sharing their valuable insights about Google Earth Engine with us and sparing their time for us. I also want to thank our attendees for being with us. Special thanks goes to Brototi ma'am, who have supported us for conduction of this webinar. Hope to see you all in 2 months long intellectual expenditure of learning Google Earth Engine.
I would like to announce that for our registered participants, you will be getting the link for the Saturday's class in your WhatsApp group. So we hope to
Yeah.
see you all in the next class.
From the next,
And also,
madam, from the next class, we will use Zoom platform.
yes,
Okay, sir.
so whatever is the platform, so we will be sharing you with the links in your official WhatsApp group. The participants will be getting the links in the registered WhatsApp group.
Okay, ma'am.
Thank
If
you.
there are
Good night, all.
no more queries, then I think we can close the session.
Okay, madam. Thank you. Good night, all.
Thank you. Thank
Thank
you.
you, sir.
Thank you so much, sir.